Assalamu alaikum dear students. This lecture is the continuation of our previous lecture, and in this lecture we shall study NOT gate, NOR gate and NAND gate. We shall verify the truth table of the NOT, NOR and NAND logic using the diode transistor logic. Okay, so let's start with the NOT gate. I hope you already know the symbol of the NOT gate and truth table of the NOT gate. What is the operation of NOT gate using a transistor? As you know that the collector emitter junction will close only when the base is on higher potential. So when we apply higher voltage on the collector, there is only one possibility that this route will be transfer current to the emitter when the base voltage is high. Otherwise, the flow of current will block here and the output will be high. And if we apply the input A as high as 1, then the output will be 0 because all the current will flow through this collector emitter junction and will flow to ground. Okay, so we have to construct this circuit by using a single transistor. We shall use a resistance, a voltmeter, a probe and a switch and a battery to construct this circuit. You can use a resistance on the base. It's your choice. You can also make NOT gate by using a single resistor on the collector terminal and without using a resistor on the base. Okay, so let's switch a window. Let's construct this circuit in electronic workbench. Okay, so we have moved to electronic workbench. So we need a transistor. We shall take an NPN transistor. Okay, we need a resistor, then we need a DC voltage source. We also need one switch and we need a voltmeter. We need a probe and we also need a ground terminal. The ground is here in the sources. Okay, now we can connect all these components to form a NOT gate. So let's proceed. Okay, I will rotate this resistance and this resistance can be connected with the transistor. I will flip this switch horizontally and by double clicking on the switch I can control the switch by using the A button of my keyboard. Then I will double click the battery and I will apply the voltage. You can use 5, 6 or whatever you want. Okay, I will use 7 volt and here 7 volt have been set on the battery. So let's connect the terminals. I have connected the base terminal to the switch. I have connected the collector to the resistance. Then simply connect the emitter to the ground. I have to take the output from the collector. So I will attach the voltmeter on the collector. Then the next terminal to the ground. Okay, so we have to apply logic high on one side of the switch and logic low on other side of the switch, but we also need a ground terminal. Okay, so I have applied logic low and logic high with the battery. This resistance should be connected to the positive terminal of the battery because we have to apply VCC voltage source to this resistance. We can change the value of this resistance. As I have already said that we can use a resistance on the base. It's your choice. Okay. So let's attach a resistance so that we can use this circuit according to the circuit given in the conventional form. Okay, so I have placed this resistance here. Now you can see that if I switch on the circuit, I have switched on this circuit, you can see that the voltage is 7 volt on the input and it's 0, but the logic is high on the output. You can check it by using a probe. So let's connect the probe. I will flip it horizontally and I will attach this probe here. Okay, now you can see that at logic low, at logic 0 it's giving high, logic high 1, and if I press the A button of my keyboard, it will shift to logic high on the input of the transistor, on the input of the NOT gate, and the logic low is on the output. So this is the basic NOT gate. Okay, so let's move to the next circuit. Now we shall verify the logic NAND gate by using the diode transistor logic. So this part of the circuit is a simple AND gate that we studied in our previous demonstration, and the next part is a simple NOT gate. I hope you already know the symbol and truth table. So let's move to the construction of the circuit. So we shall use 2 diode, 1 resistance for the AND gate, and after the construction of the AND gate we will attach a NOT gate at the end of an AND gate, and the whole circuit will be a NAND gate. So we have to form this circuit on electronic workbench. You can see that we need 2 diode, 2 resistances, 1 transistor, 1 voltmeter, 2 switches, and a DC battery and a ground. So let's start with the circuit. Okay, so I have to switch with the window to the electronic workbench. So I'm going to remove this circuit. I have to remove this NOT gate circuit. I will simply select and press delete button. Everything will be deleted. Okay, so we shall use 2 diodes. I will drag 1 diode, then I will drag the next diode. After the diodes we need a voltage source, and we also need ground terminals. Okay, we need a voltmeter, we need a transistor, we need a probe, and we need 2 resistances and switches. So we have to apply 2 switches, and we also need a resistance for the AND gate and 1 resistance for NOT gate. Okay, so let's connect all these terminals to make a NAND gate. So I will rotate both of the resistances. I have rotated both of the resistances. So first of all I have to make a AND gate. So I will flip this diode horizontally. Then I will connect these diode with these switches. I also have to flip the switches. Then I will connect the switch to the diode, one switch, and it's the next switch. Then I will select A on a switch and B on the second switch. Okay, this voltage can be set as 7, 8 or 6, whatever you want. Okay, so let's connect both of these diodes, and then I will attach the resistance here. Then I have to attach the resistance with the voltage. Upper terminal of both the switches is on logic high, and lower terminal of both the switches, you can see that I have connected both of the switches. Then I have connected them to logic low, and I have also attached a ground terminal here. Okay, so what we have to do next is we will attach this resistance to the higher side of the battery, higher voltage of the battery. Then I will connect the transistor base to the output of the AND gate. This resistance will be connected with the collector terminal, emitter terminal will be grounded. Then I will connect this voltmeter to the collector side of the transistor. Okay, then the next terminal of the voltmeter would be connected to the emitter side of the transistor, and this probe will be connected at the end to check the output. Now you can see that if we are applying 0 0 on the input and the logic is high, the output is high. As I apply 0 1, then I will press the B button and it is on 0 1, and again the output of logic AND gate will be 0 at 0 1, but after inverting the operation by using a NOT gate, the output is high, and again at 1 0 it's remain high, and whenever we apply 1 1, here you can see that the A switch is on logic high and B switch is on logic high, so we have applied 1 1 combination and the output is 0. So it's all about the logic NAND gate. Similarly, we can construct the logic NOR gate. So let's see how we'll proceed for logic NOR gate. So you can see the circuit diagram of logic NOR gate, in which we shall use 2 diodes and then a resistor. This resistor can be connected to the ground or simply to the base of a transistor, and this part is showing a NOT gate and this part is showing an OR gate. So it's the symbol of NOR gate, and hopefully you know the truth table. I will quickly move to the construction of the circuit. So let's proceed with the construction. You can see here we shall use 2 diode, one transistor, then a voltmeter to check the output, and a DC voltage source at the input, and 2 switches. So let's proceed it with the electronic workbench. Okay, so I will remove this NAND gate circuit by selecting all the terminals and by pressing delete button, and all the terminals will be deleted. Okay, so we need two diodes in forward direction. We need two switches. I will flip the switch horizontally, the second switch, then I will flip again the second switch. This switch should be set on A, this second switch should be set on B. Okay, then I will connect these switches with diodes. Okay, then I need a voltage source and a ground, and we need a transistor, an NPN transistor here. Then we need a voltmeter, a probe, and according to the circuit diagram we need two resistance. We can also use one resistance, it's your choice. Okay, now we have to connect all these terminals. So let's connect both of the diodes. I will use this resistance later on to show you that what will be the role of this resistance. So let's connect without this resistance. Okay, rotate the resistance and connect it on the collector terminal. Then it should be connected to the high voltage. This time I can set 6, 7, 5, 4, whatever you want. Okay, then the upper terminal of the switch is on logic high, and upper terminal of the lower switch is on logic high, and lower terminal of this switch is connected with the low potential of the battery. Okay, so as I said, we shall use this resistance later on. So let's see, in this diagram you can see that we have attached a ground here and attach another ground here. You can make a connection with a single ground, it's your choice. So you can use this resistance, okay, or you can proceed without this resistance. I'm showing you can use this resistance. I'm constructing this circuit at the moment without this resistance. Then what will be the effect? So okay, you can see that I have completed the circuit diagram. Okay, so now it's a complete circuit diagram. Now I have to connect the voltmeter, then I will connect the probe. I will flip it horizontally and attach the probe to the output terminal. Okay, now I have to show you something. Sometimes you can have error messages in electronic workbench, and how you can handle that error message I will show you in this experiment. So you are watching that the diode switches are at 0 0 and the logic OR gate will give output as 0, but after inverting the output is high, and if I apply A on 1, it's giving an error. Okay, what is the error message? You can read it from here. So it having some trouble with the ideal behavior of a transistor, or it can have trouble with an ideal behavior of a diode. So it's giving error due to the ideal behavior of the transistor. So we can change the model of the transistor. I will select the bipolar junction transistor, the model. you can see that it's 3904, and after selecting this there is no trouble. Okay, now you can see that if I press 00, it's 1. If I press 01, it's 0. If I press 10, it's 0, and if I press 11, it's 0. Okay, so it's all about the logic NOR gate. So you can see that I have made this circuit without using this resistance, and if you can attach this resistance on the base of this transistor or with the output and between the ground, it will also work in that condition. So it's all about the logic NOR gate. We don't need this resistance. You can use this resistance, or you can make an OR gate without using this resistance. Okay, thank you. Allah Hafiz.